Hello guys, this is Vladimir Pyntia and my first laboratory work at Security Information and Communication Protocols. And our goal was to create a client-server application which can handle multiple clients and take some special commands. What is a client-server architecture? Client-server model is a computing model that acts as a distributed network which connects the server provider with several clients, requesters, which actually request the service from this provider. Okay, and what gives us possibility to create this client-server application and to connect the requesters with the providers? Basically, these are sockets. Sockets are nearly everywhere. I'm only going to talk about iNet sockets, which are IP version 4 sockets. At least they cover 99% of sockets in use. So, first let's make a distinction between a client socket, which is this one, and of course, the client socket and the server socket. An endpoint of conversation is the client socket. The server socket, it's like a switchboard operator. The client application, your browser or your mobile phone with its built-in uses client sockets exclusively. The web server uses both server sockets and client sockets. Various forms of IPC, which stands for the inter-process communication. Sockets are by far the most popular. They were invented in Berkeley as a part of the BCD flavor in Unix. They appeared like wildfire on the internet. They spread like wildfire with the internet. Okay, what will we use to make these connections possible? This network layer. We will use the IP. And at the transport layer, this one, we will use TCP. What are these two strange abbreviations? Actually, TCP is the Transmission Control Protocol. It is one of the core protocols in the Internet Protocol suite. TCP is one of the two original components of the suite, implementing the Internet Protocol, this one, and therefore the entire suite is commonly referred to the combination of this TCP/IP protocol. The TCP provides reliable, ordered delivery of a stream of bytes from a program of one computer to another program of another computer. TCP is the protocol that major internet applications such as the World Wide Web, email, remote administration, file transfer rely on. And the IP protocol, this one. The Internet Protocol is responsible for addressing hosts, this one, to routing diagrams, which are here, basically, not in the internet, but in our routers, to the destination hosts across multiple networks. It could be not only one network. Basically, internet is a set of multiple networks to the destination hosts. which basically are the clients. For this purpose, Internet Protocol defines an addressing system that has two functions: identifying hosts and providing the logical location service. This is accomplished by defining standard datagrams and the standard addressing system, which we will speak later in this video. Okay, so let's jump in actually to the programming part of this laboratory work, and the tool we used is Python language, which is a friendly one in my opinion. It's not very hard to understand what you need to do. It has very friendly syntaxes. So and the IDE which I used actually was the PyCharm. The server, which has to create a socket and bind it to an address, a local host address, which actually is 127.0.0.1, and a port number, which is something between 0 and 2 to the power 16. Any number in this range you can choose to be your port. Okay, when we bound this socket to this address, to this network interface, and this address with a port associated, the server can start listen and wait for a connection from the client. When he listens, he also should be ready to accept a connection. When he accepts a connection from the client, he is ready to receive some data or to send some data, because actually bidirectional connection. Okay, from the client's part, what should client do? Client also should create a socket object, which actually also will be defined with an address and the same port, in order to connection be possible. When this socket object is created, it can now connect to the specified address, which is already listening and waiting to accept this connection. When the connection is accepted, the three-way handshake connection established, we can verify it using the netstat. This is only theory. Later I will show actually how it looks. Okay, when this connection is established, both parts are ready to send data or receive data, to send data back or to receive data from the client or from the server. When all the data is sent, we reach the points when this connection has to be ended. Actually, to end the connection, someone from these two parts has to close this connection. Because there is a possibility to close the connection from both ways, I think it will be logically to close the connection from client's part by sending a message to the server that you want to close a connection. When the server receives this message, he actually knows that you are going to close the current connection, and it's closed by him also. And the both socket objects are destroyed and the connection ended. Actually, the client-server architecture is built in such idea to give us a possibility to close connections, our remote connections from the clients, only one way, because the server actually has to remain alive. This is why we close the client socket, but the server socket is in an infinite loop which continues to wait, listen, and accept connections. And one remark. Actually, when we bind an address to a socket, we also make a possibility him to wait to 5 incoming requests, which will be stored in a queue that other connections would have a possibility to connect. So now let's analyze all this stuff. Actually, live example. So this is my server application, server part, which has a lot of imports, but the most important is this one, import socket. It gives us basically all the functionalities to make our connection possible. Also, I imported different libraries, which are system library, time library, the thread library, OS library, and random generator library, which I will use basically in my special defined functions. Now we can hide this. So first of all, as I said, we have to create the server socket. Let's zoom in a bit so all would see this. So first of all, we have to create a socket object, which will associate the name of the server socket because we'll use it on the server. Then we'll print our mess was server socket was successfully created. Then we are going to bind this socket to the address of localhost, which is the address of my computer, at the 55,555. A long one, but it's in the possible range to connect it. After we bound the server, we can start listening. The server socket will now start listening to 5 connections, actually, 5 requests. And for a separate purpose, we set up a timeout. Actually, the accept function is a blocking one, and we set this timeout in order to create and try accept clause, which will generate an exception, so we won't be in a blocking state. So, okay, our program actually has a possibility to work with multiple threads. This is why I will hide for now the defined function for handling these connections, and we will speak about the main function. In the main function, actually, I implemented an interesting trick with the listening and the loading cursor, which does not give a lot of functionality, but it's very nice to watch it spinning. Okay, then I'll show you. So then this is actually the listening cursor, which is on a timer, is moving by drawing different symbols in sysstdout right, which is type 0, type 1, type 2, type 3. And if type is the last one, then it changes it type 0 and starts over again, and it flashes at flashes. at a rate of 0.1 seconds. So the try except clause actually tries if there is an connection to accept, it accepts it. If there is not, it generates an exception which actually verifies a flag which is set to 0 for now in order to not shut down the server. Then it continues to the accept the address, output the remote address, which is stored in the variable remote address, and creates a new thread, starts a new thread which has to receive two parameters, which are the function handler, which handles our connection, and actually the information about our connection, the client socket and the remote address. To go farther, now I will show you actually the function, how it looks. The function is defined oh, what the fuck did I did? Oh, that's nice. The function actually is defined by having two parameters, the client socket and the remote address. I put it into the infinite loop in order to receive commands like all the time, to be ready to receive some commands. Okay, actually it receives a set of bytes. So after I received some information from my client socket, I print it out in order to show which was one of the commands, and then I analyze this received information. If the string I received actually is time, I output the time in a standard form, which is hours, minutes, seconds, and send it back through the client socket to the client, sending directly the string with hours, minutes, seconds. Another possibility is to send a show time command, which is slightly different because this command actually gives us a possibility to send a picture to the client. So the showtime command actually sends a picture to the client. First of all, we have to open this file, which is picture to send.jpg, which is stored in the same directory with our application, with our source codes, and we have to open it in the read byte mode. After we open it, we should read it, which will be stored in the variable data to send. After we read the file, we have to send this long string, which was read from the image, to our client, which is client socket.send data to send, and we print out actually the amount of data we sent by associating it to the variable a and printing it out. Then we should close the file. The command to receive is the close function, which actually will send a string by byte to the client and close the connect server's part. So another function which we can send is the Astalavista function, which actually has a global variable kill. When the server will receive this function, this command actually, this global variable will be set to 1, as we saw lower this part, we initiated it with the value of 0, which gives us possibility to not exit and kill our actual server. So this Astalavista function, it also sends a special string to our client, and the client closes the connection from its side, and from the server we also close the server socket basically, and then exit from all the loops, and definitely closing our server. Yes, shutting down the server. I suppose I made some... No, it's okay. It's okay. We also have to do here the client socket closed, not the server socket closed, because the server actually is closed lower. Okay, in that if loop where we verify the kill function. So the next function which we can receive from the client is a greeting, hello server, or some teenage version, hi serve. So, and by receiving this string, the server actually will respond in a slightly intelligent mode, hello client. Also, one of the functionalities we had to implement is when a server receives a string with a question mark at the end, it should send it back the number 42, associated with an opera, I suppose, written by some very cool guy. Who's interested can search it out and solve this mystery. Okay, and now we will go to the second my functionality I implemented, which is verifying if in a string we send is found a specific word. So this is done by the keyword at the beginning of the string received is str space or str with the lowercase space. So the server received object verifies the first 4 bytes, first 4 characters actually. Then it associates to D the next from the fourth position to the end of string, and it verifies if there is present the string bubbles, the word bubbles in there, and it sends back the conclusion. Either there is bubbles found or there is not bubbles found. So the next functionality I implemented was the kitty. When the server receives the kitty function, it sends back a nice ASCII kitty, which I was inspired from one of the Win Fortune videos of our teacher, Alex Raelian. And what do? We use the library OS in order to open the kitten storage, which is the folder kitty located in the same directory with our program. We list this directory, all its files from the kitten storage, and we receive actually an array of files. Then we randomly select a file, which is the random choice of A, also used from the library random. We join the full path to the file in the variable path using the os.path.join between the kitten storage directory and the file of the selected kitty. Then, as in the file transmission of showtime, we open this path to the file, read the whole file, and send it to the client. So now I would like to show you actually how these files look like, and they look like this. SIPC. So this is our folder kitty, the listed directory, which is kitty123. I also can show it how this function works in here. No, I will definitely open another window. So, and then I will write Python. It should work, yes. Okay. Oh, here. Actually, it works. Actually, it works fine. So this is why we received. We received actually the list directory of the current folder, which we were running, the CPC1 folder, and we received an array of names of folders and files we have here, list directory, listing all the files. This is all I wanted to show you, how it works actually. And then when we join this path and the selected file, join the path with the selected file, we can open the file actually and send the image. How does the image look like in the file? So this is our files, which are beautifully named, like first kitty, second, third kitty, to random choice. Select the file, and basically our kitties look like that. Nice ASCII art with good spacings, basically made in Notepad. Why didn't I use Notepad++? Because when the first time I tried to make these kitties look nice, it didn't work because Notepad++ made some special tabulations, and when I actually tried to read the whole file, some of the parts were moved like to the left, and this is why I edited them in the Notepad basically. To mention, we actually have to use the ANSI encoding, the ASCII one, not the Unicode, because it's slightly different. So, and the result will be that beautiful ASCII art, which the client will receive. And of course the last functionality, which isn't like a functionality, but when the server receives some unknown commands, actually it sends back the question if you can elaborate on your request. So that's all with our server part. Now we will go to the client's part. It is slightly simple, which is easier to understand. It's not such complicated code here, and actually we used the socket library, the address, and the port we want to bound. Not bound, but actually we specified the address to connect. It's not the server, it's the client. And then to send some data, we use the raw input because it gives us a possibility to write an entire string, and on the keystroke enter send this string actually to input it. This is raw input and very useful function. Then the client socket, which established the connection with the server, sends this message, which we inputted and at the keystroke enter send it to the server. And we show actually what do we send. And as the show time is a very specific function, which should be ready to receive a picture, we defined it in such a way. We verify if the message is show time, then we prepare an empty file, which we open in the write bytes mode, which is called picture_received.jpg. Then we set a timeout of 1 second in order to our try clause to receive sets of bytes append in a long string, which is client received client socket.rec, and then write them to our file fwrite client received until the exception, because our TCP packets are stream 1. They transmit all the data in a stream, and when the exception is called, actually is received, we close the file. Then go out from our infinite loop while true, and setting the timeout back to none in order to not affect any other parts of the code. It's not necessary actually, but I did it. Print out a message I received from server file to the client know that the transmission actually finished. If there were other simple commands called, it does nothing. It only receives the information from the server. Client received the set of bytes, which it prints out after the message I received from a server, some information. This \n isn't very useful here, because actually it's not very important formatting. And of course, we implemented our close and Astalavista functions. The close and Astalavista functions basically send to the client a message, specific one. One is bye-bye, which shutdowns the client, which closes actually only the client. And the other one is the down, which comes from the Astalavista function. The first is from the close function, and the second is from Astalavista function. Actually, from different sources which I read about closing and shutting down sockets, there were mentioned that it is not necessary to use the shutdown function with the 3 possibilities. If we set it 0, it's not writable, I suppose. Yes, if we set 1, it's not. It does not read data, and if 1 it does not write data, and if it's 2, it either it doesn't make both, not write and not read data. And the close function basically makes all the cleaning work, and then we exit actually this connection. And also I think it's not very useful, the last client socket close, but let me think a moment. If we close shut down the function here, yes, it's not necessary basically to do it in the if clause. We can also do it outside the if while close the client socket. So basically this is the comments on the source code. Now I would like to show you how it works. For this we will start our command prompts. So basically cls no. Okay, we can make it here. So first of all, we would like to start the server. What the doesn't work, does not want to work. So we will start the server now. Python server.py. So as we see, the socket was successfully created, the socket was bound, and now it's listening for an incoming connection with this beautiful spinning cursor. So let's connect one client at the beginning. Python client.py. Oh, Cleton. Cleton.py. Client.py. So the socket was also successfully created. As we see, the server showed that he accepted a connection from the address 127.0.0.1 at the port 34440, which isn't the port we specified, but basically this happens because waiting for connection at the X port, the client sends it a request in a such a way. But basically the network stack on the network interface is based in a such a way, and sockets gives us possibility to redirect this connection to a different port. Why? In order to not block this port, which is X. This is why we have this possibility to connect, and the waiting queue here is of course 5. In the same period of time, if there will come 5 connections, they will be stored in this stack, and when this magical redirection will happen, the next client will be served. So now let's try to call some functions. The first function will be time. We want to know what time is now in Chisinau. Actually, it's quite late. It's 00:05:25. So as we see, also the server received this command and sent us back. Actually, the information appeared on the server's part later, basically because of the timeout set, which is I suppose 3 seconds, which I put. In that period of time, it is listening, not very long. Because of this animation of like 5 seconds, it makes a little timeout in receiving, actually printing out the command, because he received it faster and already sent the information back. Okay, the next command we would like to try is hi serve, and the server answered hello client. Another command which would be let's look at the kitties. Kitty, and it sent us back a nice SG art of the Hello Kitty. As you saw, I implemented different combinations of string you can send, with the uppercase, with the lowercase. So the next would be hello server we used. Let's verify a string now and then ask a question. So verifying a string, let's write str first 4 positions, and then let's write mabla wabla babla gabla bubbles mabla gabla blah blah, and actually the word bubbles was found in the string. Of course we can try it also without any bubbles, and the word bubbles was not found in the string. Now we can ask a question. Okay, but there is an idea. What will happen if we will both write an str space bubbles and put a question mark at the end? Actually, it's very interesting. Because he gave bigger priority to the command with the question mark than to the command str bubbles. Okay, I'm sure it will work fine without the question mark, of course. And then let's try actually to send and receive a file. For this we will need to delete the basic file from the directory with the kitties, not the kitties. Here we have the file to send. It's like this. It's our terminator from the second part, and he was ready to kill himself, and he said Astalavista baby. So we will erase now this image permanently, delete this file in order to not confuse our server and client. And now we would like to ask. Let's ask it from another client. Actually, Python client.py. So the connection was established. As we see, we received on the slightly different packet this connection. Here it is 36440. This is 36450. It is totally random pulled. So now we should input the command show time, which, as I said, show time. When the server will receive this command, open the file, read it in a set of string, read it in a long string, then receive it, then send it. The client will receive it in an opened empty file, which will be ready to write this string in, and then just save all the stuff and close the files and give us the message that it received actually a file. So send to the server. As we see, the showtime command was sent to the server. The server received this command, opened the file picture to send.jpg in the mode read bytes at the pointer, and passed us 20,000 bytes, of course. Yes, 20 kilobytes, I suppose. And our client wrote that it received actually the file from server, and we can look now at this file. It magically appeared here, the picture received, and we can open it. It's our picture of the almighty Terminator, the Terminator, which actually did not die. Okay, now the last function which I would like to show you is actually, let's make one more kitty call to verify actually the random choice generator. Oh, here it is. Oh, all three kitties set up together. Hey, kitties! Now we show the functionality of the close and the Hastalavista function. I think we should try to open a new client to first show the close function, then the Astalavista function. So cpc1, then Python client.py. So the new socket was created. We can verify it, and one more, and now we should close the connection, sending the function close received from server by byte. So the server also received the function by close, and this is what we received the by and actually the socket was closed. Okay, actually we also connected once again two clients, client 1, client 2 at these ports, and now we'll try to send the Astalavista function. And hopefully it should work correctly. Yay! It worked perfectly. So this is what we've done. We sent the Astalavista function, which sent this message to the server. Server received it, closed the client socket. No, firstly, send the down command to close the socket, the client socket at the client. Then actually closed its own socket and then shut down the server. Close the server socket. As we see, now we can write the netstat and see that actually we have no connections from the server and either from clients. They, as I can show you higher when it worked properly, look like that. This connection and this connection and this connection closed, wait, finish, wait, second, time, wait. Actually these connections were waiting to become closed, to destroy themselves and just to erase them. So, but actually there is a nice interesting dilemma. The client which was connected at the same moment of time with other clients before the server got shut down didn't receive anything, and isn't knowing that the server socket was closed and there is no connection. This is why actually we can implement some try except implementation with a timeout set, which will verify if the connection is alive. Need to do this. I actually didn't implement this, and when at the next state when we'll try to send or receive some data, we will have an error which says that the existing connection was lost, for the remote was forcibly closed by the remote host. This is all about this laboratory work. Thank you for your attention. If you have questions, I am ready to answer them with great pleasure. Forever yours, Vladimir Pinta. Good day.